So here we have the 2014, this is Junior Cert Coordinate Geometry questions, and we're asked to plot the following points. So A is 3, 1, B is 0, 4, and C is -2, -1. What comes first is the x coordinate and then the y coordinate. The x-axis is the horizontal axis, this is the positive x, this is the minus x. The y-axis is the vertical axis, this is the positive y-axis, this is the negative y-axis. So if to plot the point 3, 1, we have to go across to 3 on the x-axis and then to 1 on the y-axis. So this would be A here. And then to plot the point 0, 4, well, 0 is just going to be on the y-axis. When x and y are 0 at this point. This point here in the middle is 0, 0. So all along this axis, x is 0, and all along this axis, y is 0. So if we want to plot 0, 4, so it's 0 for x, and then 4 for y. So this is B, which is 0, 4. And then if we want to plot -2, -1, so we have to go across -2, and then down -1. So this point here is C. And then it says, by calculating A, B, and BC, so we have to calculate, when it says when there's AC and there's two lines outside, that means the length of. So the length of AC. So C is -2, -1, and A is 3, 1. So if we want to calculate the length of this, we're going to have to use the distance formula. So this here is our distance formula. So the distance is going to be x2 minus x1 squared plus y2 minus y1 squared. So we have to label one of our points x1, y1 and the other x2, y2. It doesn't matter which one we pick for x1, y1. So as long as if we pick one, the x to be 1, then the y of to be y1. So it's x2 minus x1, so 3. When we have minus, I'm just going to put -2. And then that's squared plus y2, which is 1, minus y1, so -1, so that will become a plus. So then we have, I'm just going to deal with the signs first. So minus and minus is a plus, so that will be 3 plus 2 squared, and then 1 minus, so that will become a plus 1 squared. So then that's going to be 3 plus 2 is 5 squared, and then 1 plus 1 is 2 squared. So that's going to be 5 squared gives us 25, and 2 squared gives us 4. So it's going to be the square root of 29, and that's not a square number, so we can't get the square. So we're going to just leave it in that format. That's called third form when we leave it with a square root. So we are asked to show that the length of AC is equal to the length of BC. So we're also going to have to get the length of BC and show that it's also the square root of 29. So B is 0, 4 and C is -2, -1. So just the same as before, we're going to have to label one of our points x1, y1, and we're going to have to label the other x2, y2. So we do add our formula. So the formula is x2 minus x1 squared plus y2 minus y1 squared. And when you have two lines on the side of it, that means the length of the line BC. So we're going to just plug this in. So x2 is -2, and then minus x1, so that's -0 squared, and then y2 is -1 minus y1, which is -4 squared. So -2 minus 0 is just going to be -2 squared, and then -1 minus 4 is going to be -5 squared. And if we square a minus number, a minus by a minus gives us a plus, so this -2 squared will be 4, and 5 squared minus 5 squared will be plus 25. So then I get the square root of 29. So BC is equal to the square root of 29, and we just showed that AC from this part was also the square root of 29. So AC is equal to the square root of 29. So by that, BC is going to be equal to AC. So we're after showing that BC is equal to AC. And then it says, what type of triangle is ABC? So I'm just going to draw, I don't have a ruler at the moment, but I'm just going to draw the lines. So what type of triangle? Well, we've shown, say this triangle, the triangle ABC, that just means ABC are the corners. So, well, the length of, we got the length of AC, this length here was the square root of 29, and we also showed that BC was the square root of 29. So when we have a triangle that two sides are the same, well, we can say it's an isosceles triangle. So what type of triangle is ABC? So when we have two sides the same, so say if this side is the same as that side, we can say it's an isosceles. Is an isosceles triangle. And then D is the midpoint of AB. Find the coordinates of D. So if we want to get the midpoint, so there's a formula for the midpoint, so just get that here. So the midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. So the midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. So we want to get the midpoint of AB. So A is 3, 1, and B is 0, 4. So it doesn't matter, we just have to label one of them x1, y1, and the other x2, y2. So x1 plus x2, so that's going to be 3 plus 0 over 2, and then y1, which is 1, plus y2, which is 4, and then that's over 2. So then I get 3 over 2, so 3 over 2, and then that's going to be 4 plus 1, which is going to be 5 over 2. So I can leave it at that in fraction form, or I can say that's 1.5, and then 5 over 2 is 2.5. So it doesn't matter which way I leave it. So that's going to be the midpoint, and this here is D. So then it says, draw the line CD on the diagram. So D is 1.5 on the x-axis and then 2.5 on the y. So D is going to be about here. So this is D, and it's the midpoint of BA. That means it divides BA into two equal sides. And we are asked to draw the line CD. So in the exam I would be using a ruler, but I just don't have one right at the moment. So draw the line CD, that means draw the line from C to D. And then we're asked to show that the triangles CBD and so BDC and ADC are congruent. So if I want to show that two triangles are congruent, they're saying use SSS or SAS. So what does that mean, use S? So I'm just going to get this on a different page so we have it. So this is my diagram here. So if I want to show that triangles are congruent, the ways that they're giving me is SSS. So that means side, side, side. If we show that the sides of two triangles are the same, well, the sides of two triangles, they all have the same sides, well then we can say these triangles are exactly the same. Congruent triangles means the triangles are exactly the same. Triangles are exactly the same. Incongruent triangles, the sides are the same and the angles are the same. Congruent triangles, all the sides and angles are the same. The sides in the two triangles and the angles in the two triangles are the same. The sides in the two triangles and their angles and the angles in them, the angles in each are identical. So congruent triangles are exactly the same. So if they're congruent, I want to show that they're exactly the same triangles. So SSS gives me side, 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 and they're also giving me another option, SAS. This means side, angle, side. So if I can prove that two sides are the same and then the angle in between those sides, well then I can show that they're also congruent. So I think I'm going to be able to use the first one, side, side, side. So firstly, if I want to show that, so say looking at this, I'll just maybe do kind of a bit here for to my proof. Well, firstly, if I'm looking at this triangle here and this triangle here, so I might just underline them in a different color. So the triangles that we're looking at is this one here, so this one here, so this one here, and then this one. So I'll just get a pen to underline. Sometimes it's handy to draw them in a different color just so you can really tell which one is which. And then this one, so there's this one here, and then so I'll just draw them both in red. So we're comparing this triangle here and this triangle here. So the first thing is they both have the side CD. So they both have that side. So well, that's going to be the same in both of them because it's just the same side that each of them have. So I'm just going to write CD is equal to CD. They both have that side, so that's a common side. And then, well, didn't I just show already that CB and CA were equal? I showed that in the first part of the question in part 2. I showed that AC, that was part 2 of the question, is equal to BC because they were both the square root of 29. But D is the midpoint of BA. So that means the distance from B to D is the same distance as D to A. So D halves the line BA. So BD is equal to DA. D is the midpoint. D is the midpoint. Well then, because all the sides are the same, I can say by side, 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 the two triangles are congruent. And if I can show that each of the sides are the same, I can say that the two triangles are congruent. So that is our question. Thank you.